Welcome to this week's Weather Watch. Also like to introduce in the back room, we have Dr. Louis Cellini, a alum of our program. He's the director of the National Weather Service, and he's in town for an event tomorrow that's going to be near the airport, Dark Skies event. You've seen posters around. It's open to the public, so I encourage you to attend. John Martin's on travel, as well as Greg Tripley, so you have me today. And what we're going to do is just, this would be somewhat abbreviated discussion, but I encourage everyone in the audience, including Louis, if you'd like to chime in about some of the aspects of things we're talking about today. I thought I'd first start off with the Madison climate data. First of all, just the temperature. The reason I bring this up is because, one of those food trucks outside Muskorican canceled their service yesterday because they said something to the effect that we're going to cancel today because, Mother Nature hasn't figured out that it's spring yet or something.
Wisconsin doesn't know that it's April is what he said.
Right. Wisconsin doesn't know it's April yet. So what does it mean to be April in Wisconsin this time of the year? And we should be looking at temperatures that are in the mid-50s for highs. And after a brief tease earlier in the week, getting into the low to almost mid-70s, we collapsed back to a day with snowfall, a couple inches of snow at the airport reported just 2 days ago. And so we'll look at the last vestiges of that storm as it begins to spin down over the upper Midwest over the next couple of days. And I will note that in our forecast for the next week, we have 2 more shots at snow, again on Sunday, particularly for the southeastern part of the state, and maybe a more widespread event a week from today. So we'll check that out as well. Again, far out, but last week we were talking about the possibility of snow during this week, and it certainly came up. Certainly occurred.
Fixing the screen, not going to the edge of the spot.
A few technical issues. Move on. Again, from our state climatologist office, if you look at the Madison water year that begins in I think it's November, early October actually, 1st of October, you can see we're running well above normal at this point. And there's that the last event that we just had that was liquid precip. As for snowfall for the season, you can see we're running well above, and there's our 2-inch jump right there. And maybe we'll crack 60 before the end of the month. We'll see how that works out.
These graphs are from the state climatology office, and they've got these images for going back like 20 years or so. So if you're interested in looking at previous years, right, take a look at their website.
And we have them for sort of major cities around the state.
Right.
All right. Let's go to, first of all, visible imagery over the upper Midwest. We're going to take a step back for this in a moment. What you can see is just a really nice satellite imagery, visible satellite imagery with sort of color, close to true color, I guess. But you can see this broad swath of cloudiness over the upper Midwest, the swirl associated with, again, this now decaying cyclone that's located over south central Minnesota this morning. You can see predominantly low clouds, a few stratocumulus on the edges of this, but fairly, these are shallow stratus clouds. Just look outside and see that. You can see some high clouds that are also on the western edge of this circulation center, to the northwest of the circulation center. And this is largely driven by, with the cyclone beginning to decay, I'd argue sort of an Ekman pumping in the boundary layer. You have surface convergence in the lower troposphere that's going to give rise to some ascent. We have a nice stably stratified environment. There it comes in, up, then just begins to spread out divergence in the lower troposphere that ultimately is the source of the spin down for these large-scale cyclones. Further to the east, you can see a band of some high clouds that are streaming well ahead of the weather system. You can see the shadows of those clouds as the animation begins over parts of Lake Michigan earlier this morning. And we had a nice period of fairly significant rain last night, and a little bit of embedded thunderstorms before the cold front associated with the system went through. We can step back to a larger scale North American view from this view. Go to 6 hours. And you can see this circulation center over the upper Midwest, but again, a broad swath of the eastern 2/3 of the United States is influenced by this particular system. And you can see, even as the clouds begin to erode, there's actually some evidence of a snow line. You can see where the snow accumulated from just northwest of Lincoln, Nebraska, and Grand Island, Nebraska, all the way up into parts of Michigan. And if you go into parts of our state, Townsend, Wisconsin, up in Oconto County, right up about here, received about 1 foot of snow. And just Green Bay, about 3 inches of snow. So a pretty decent accumulation in the northern part of the state. with this particular cyclone. But this is an impressive event that I'm sure John would just love to be talking about with latitude cyclones. But I'm not going to say anything about tropical cyclones, one because there's not one on the map, at least to show today. But this is maybe one time, don't tell them I said this, that this is an impressive looking cyclone. All right. So you also see some high clouds streaming out of the desert southwest. This is ahead of another weather system that's going to be impacting us later this weekend. And we'll take a look at that when we look at some of the upper air charts. But that's sort of the stage. The stage has been set for this. Let's next go to the radar imagery.
Did you see the other day the dust that got kicked up? There was a lot of talk on Twitter about how the snow that was coming down in Minnesota, it had like an orange or a brown tinge to it. And if you look at this loop, I don't have it handy, but from was it Wednesday? Mm-hmm. There were really strong winds over the desert southwest that were kicking up dust, and you could just see it being transported right up and getting sucked into the storm, right, and coming down.
Actually, we'll look at a surface map for the radar, but if you could keep this up for just, you can get the surface map right now. Two other really notable aspects of the storm, or one specific one, is the intensity of the storm as it moved into the central plains. When it was over parts of, I think it was in Kansas, western Kansas, it was down into the low to mid 980s in terms of its central pressure, which is near a record for parts of Kansas. So we've had two really intense cyclones approaching sort of record values over the last month that have had a similar track off the southern parts of the central part of the Rocky Mountains, moving into the central plains and then moving up to the upper Midwest, both creating blizzard conditions. So that's kind of an interesting feature of the weather pattern of the regime that we've been in over the last month or so. That's been conducive for this, and we get such energetic storms with record-breaking sea level pressures in the central part of the cyclone about a month ago, and this one near record, but not actually setting a record. You can see, again, in the surface observations, a little bit of a freezing drizzle of 31 in southwest and southeastern Minnesota. The Twin Cities, 35 over 32 with light snow. So broad area of light snow underneath this large-scale geostrophic or near geostrophic circulation with a frictional convergence occurring. That's going to help, again, produce this ascent and the low clouds and very light precipitation. That's kind of characteristic of that. Further to the east, ahead of this system, back in Maryland, let's say, you can see a national airport here in DC, 69 over 58, so pretty warm day this morning. The west, we have to the west of this, actually it's Baltimore at 69. This is Dulles at 63 over 60 with moderate rain occurring. This is well in advance of this, the front associated with cyclone. But dew points finally creeping up into near 70-degree dew points over the southeastern part of the United States. So this is a pretty mild storm. And temperatures in the southeastern part of the United States and central Florida getting already today 88 degrees in north central Florida. So pretty warm day all around. You go back out to Nebraska. It'll be interesting to look at a satellite image here, but I mean it's cloudy everywhere right here, so you're not going to see the impact of the snow cover in terms of how the impact is on temperature with clouds everywhere. So you see temperatures sort of hovering just around freezing here. This is probably just where the snow line is and the melting's occurring. And then to the southeast of that, you get temperatures that have climbed into the middle and upper 30s. So the snow line, if you recall, on the radar or on the satellite image was right about here, just north of that line. That's where you see the melting temperatures suppressed somewhat with that, but without full sun, you're not going to really see a big difference in temperatures there. All right, let's go to the radar.
One of the multi-spectral images might do a pretty good job of finding that the snow line versus clouds.
Okay.
We go here. It's this day cloud phase distinction map. It only really shows during the day. The red channel is infrared, so it shows up at night, but this green over here is snow. Okay. And the blue and the blues and the reds and the yellows are clouds. So you can see here's the snow line.
Now, how's that done? Can you speak to that a little bit?
There's 16 different channels on GOES 16, and this uses 3 of them. I'd have to look at the actual description of how that happens.
26 and 1.6.
What's that?
25.5, 26.8, and 4.26.
On our web pages, I've actually got a link to what it is and how you interpret it. So this is what goes into the red, green, and blue channels on there. Oh, that's the air mass. I'm sorry, wrong one. This guy. And explains a little bit about how to interpret what the different colors that you see are.
Okay. Let's see. And thanks for having that link at the bottom.
Do you want to do
Radar next?
radar?
Okay. We saw the moderate rain in Dulles earlier, and you can see sort of showery type precipitation of these band of precipitation move ahead of very likely our cold front. In the broad area of light precipitation in this decaying cyclone to the north of the center. See that's kind of spinning around the mid-level centers, probably closer to the north of the Twin Cities. And just some very light precipitation right now over the southwestern part of the United States. Nothing to get at this point particularly excited about.
What's this stuff? Chat?
That's probably chat, yeah.
Sort of military maneuvers.
There's multiple radars that are picking that up.
It's going fast. A lot of times here you see some tours that actual preset. A lot of times you'll see it out on the coast of Florida.
Yeah. Okay, so let's go to our upper maps, the super peaks. And we'll start off at, let's just work our way up from 850 after that. So,
Super peaks.
through the 801, sorry, I meant to mention that to you. So this is the 850 hectopascals. You can see this is a 12Z. Using the North American model analysis over top of our observations. And you will see that this cyclone is very nicely stacked as it's reached its mature phase, with the center this morning being located right along the Minnesota and Iowa border this morning, with the lowest heights found there. And again, this nice broad, not quite geostrophic, but nice broad sort of rain circulation located over this. And again, I'm emphasizing this boundary layer aspects of this because of the discussion we've had in 311, just to keep that in mind. We can see this baroclinicity that's to the southeast of this cyclone. Okay, so this is not our surface front, but the surface front's further to the east of this, but you can see a nice horizontal temperature contrast from southwestern Ohio, to eastern Iowa, with a difference there of almost 20 degrees Celsius. It's fairly potent front that shows up on this particular map. And you can see the warm, this trowel type structure that extends all the way back to the center over parts of Minnesota. Temperatures well below zero, freezing here, so that's where we see the light snow. Further to the east, even in Green Bay, in these areas to the east of the cyclone center, it's still relatively warm, and they're getting lit. Any precip that's falling at this point, largely lit. Go up a bit to 500. You'll see again the same structure. Slight tilt to the cyclone center from northern Iowa back to southwestern Minnesota. But again, nice broad trough that it's embedded within. You can see the large scale trough feature and a smaller scale feature located just inland, moved on shore, has moved southward from Washington State and Oregon. It's now located in the southwestern part of the United States. We already saw the high clouds beginning to emerge ahead of it, but this is a nice feature with a nice upper front on its western side, and very nice baroclinicity just on the west side of this upper front, or this trough, excuse me. And you can see downstream of it, not much curvature in the flow, so we're not going to expect much action yet with this, but as this begins to intensify and move up to the southern plains tomorrow, that's when things will get a little bit interesting over there. But I'd say this is just a fairly tranquil pattern. I mean, other than, again, it's large scale wave, it's large scale planetary wave structure, but the cyclone is, sort of a big story, I guess, of the central part of the United States. And a nice downstream ridge of it, with a changing curvature from cyclonically curved to anticyclonically curved. Broad area divergence that's just to the north of that over southwestern Ontario. Let's go up to 300 millibars, please. And here we can see a jet maximum that extends, kind of outlines where we saw that band of cloudiness in the satellite imagery in the southeastern United States into Canada. And again, this persistent circulation at all levels that we've seen from the surface up to 300 hectopascal. Those are pretty nicely there. Here's this trough and the upstream jet associated with, we saw the upper, some evidence of an upper front associated with it as well, to the southwestern part of the United States. And this is the structure, again, that's going to be responsible for some interesting weather. The plains is eventually just southeast of us by Sunday afternoon.
Hey, Mike?
Yeah.
Yeah, I think the forecasters are also focusing on that southern jet, and that will amplify
Right.
the artificial lateral jet structure. That's why they're focusing on this.
Is there weather out here
And it's bullseye over Arkansas tomorrow.
for tomorrow? Okay, so we'll look at that and look at some of the conditions for severe weather. And certainly, for the grad students that study that a lot, if you want to chime in and get to that series of maps, forecast maps for them, that would be great. But thanks for that comment. All right, let's move to the forecast maps. Go to Pivotal, please. And before we get to that, just get to the forecast, go to this homepage right here. Just outline some of the things that are going to be of interest. Again, we still, even with that departing storm, there's still winter storm warnings in the northern part of Minnesota with winter weather advisories all the way back out to south into central South Dakota. Winter storm watches that have been issued for the northern parts of New Mexico this afternoon. So, in preparation of this weather system in the southwest moving out. Looking ahead, again, we'll come back to the shorter term forecast, but I like to just get a sense of the flavor of what's coming up. This is CPC's forecast for the temperature outlook for the next 6 to 10 days. And unfortunately, if you liked our warm weather last weekend, we're not going to be anywhere near the mid-50s. Perhaps it's very likely we're going to be below that. But how much below is going to be a question. It's still a big question. But it's like, if you looked at this and tried to sort of ascertain what do you think the planetary wave structure would be, it's like a trough over the central part of the United States for the next week or so. If we go further out, for 8 to 14 days, we don't really warm up much. Even the likelihood of getting a remaining cold sort of goes up, in fact, as we move into the 2-week period. But on the flip side of this, if we go back to this for a second, we'll just go to this, we should say the flip side, we're actually going to be also somewhat wet. So below normal, wet, put those two together, and this were earlier the year, you might say snow, but it looks like at least chilly, rainy, maybe a few flakes mixed in with that over the week to 2-week period coming up, unfortunately. All right, so let's go to the forecast maps. We'll start models, and before we get to the surface, I want to just go down to their dynamics, so-called dynamics page, and look at the 2 PBU surface this morning. And so this is surface of constant potential vorticity with theta superimposed on it, and you can see some evidence of that upper tropospheric cyclonic circulation that we've been talking about extensively for the first part of this discussion. It's located over Minnesota. But here's this next weather system that's going to really be key. You can see some enhanced varicolonicity temperature contrast on the west side of this disturbance that is affecting southward. Again, on these maps, we can, with the winds, we know that we should be able to simply get the winds by advection, since this is a conserved variable on a conserved surface. As long as it flows adiabatic and inviscid, we're going to expect we can sort of just eye by advection where these features are going to move. As Louis pointed out, there's also a really intense front along the southern edge of this region on the dynamical tropopause. The subtropical jet just to the south. That varicolonicity there belies a very strong PV gradient and associated jet structure that's just to the south here. If we go ahead on this map, let's just go ahead a day to 24 hours just to look at the evolution of this. We see this trough has continued to dig to the south, and you can actually begin to see it beginning to wrap up here with a downstream, broad downstream ridge. And if we were to step through this, we can go back and do that. You're going to see that these regions here, these sort of streaky regions, I'm not going to focus on too much, but the fact that it's these little streaks of blue here that are much warmer temperature than dynamical tropopause suggests that there's perhaps been some significant latent heat release that's beginning to develop. These areas here might realize or suggest some convection as well. But this is a pretty potent upper trough as it moves into the southern plate into central Texas by tomorrow morning. We go ahead to 30 hours, we'll do this a bit slower. Clearly, these areas expanding in green are suggestive of diabatic heating along the dynamical tropopause. And so this is helping to, one, build a downstream ridge, Downstream of this, so the curvature, if you were to take this PV and invert it, you're going to see increasing curvature vorticity, changes in curvature vorticity downstream of the trough into the ridge right here. So that's going to certainly favor development of a cyclone over parts of Oklahoma. Be sort of large-scale divergence we expect in that region. You can see certainly the flow is fluid at this point, and the along flow speed changes are also increasing. So this is certainly suggestive of significant divergence in the upper troposphere downstream of this upper trough. So the situation is favorable for a cyclone to begin developing in the southern plains tomorrow morning, into tomorrow afternoon. Go to 36 hours. And more spotty warming here, which again would be suggestive of some thunderstorms, very deep convection occurring as this trough begins to move into out of the southern plains at this point. Is it going to intensify more? Well, the deeper this is going to go would be associated with pinker colors filling into this, and you can see there's some potential for induction of colder potential temperatures into this. It's still kind of connected to this reservoir of colder temperatures, but this is essentially becoming a cutoff in this feature, at least at this time. Go to 42 hours. Right. And this trough really hasn't cut off at this point, but you can see the structure of it is shifted with, again, a very strong baroclinic, strong temperature contrast on the south side of this, which would be associated with an upper front just to our south. But again, this warming here, which you can't explain solely by advection, is suggestive of non-conservative processes late in the release. Let's look at the surface maps during the same time period for the evolution to see if that's worn out. So we'll first start at 6 hours of the forecast. And please jump in if you'd like to say something. This is the first 6 hours of the forecast. This is the precipitation rate, so basically accumulated precipitation over these are 3 to 6 hours, any of this time period. Here's our light snow, or moderate snow to the north side of this by 18Z. Here's the showery weather that we saw evidence for in the radar. So at least the GFS initially in this model forecast has done a pretty decent job of depicting where those areas of precipitation are. This is instantaneous, it's just accumulated, but still consistent with what we've seen in the observation. Go ahead, 12 hours of the forecast. And that cyclone is still slowly filling. We're in some cold thickness advection at this point with our westerly winds over us at this point. Go ahead to 18 hours of the forecast. You can see pressure is falling in West Texas, 998 down to 997 at this point. It's kind of corrupted because of the mountains, but the thickness is here. Outside the thickness is a trough-like structure here. We'll go to 500 millibars at some point to look at that. Here's a perhaps nascent cyclone. You can see baroclinicity to the east. As the upper trough moves over that region of baroclinicity at the surface or in the lower troposphere. That's going to be a nice source for the spin up of the cyclone. So let's see how that works out by 24 hours. So waiting. Lots of precipitation that's occurring here. At least that aspect of it, and some heavy precipitation north of Amarillo. That's consistent with what we saw with the dynamic tropopause with the warming occurring in some regions there. So that's consistent. What we're seeing in the precipitation field is consistent with what we saw over the dynamic tropopause. Again, over us, tomorrow looks like a fairly decent day. Maybe still some clouds around, but dry at this point. Again, heavy precipitation in the southern plains, 36 hours. 999 to 995, here's the cyclone finally beginning to develop. Lots of precipitation to its east. And this is one forecast. We'll look at a couple of other ones just to see how this compares. What you can see are our developing cyclone. Our cold advection is just about over at this point. Still a weak cold advection over us. But again, tomorrow looks like a dry day. 42 hours. So this is 60 Sunday morning, or so it's 1 o'clock Sunday morning. Here's our 998 cyclone. Actually, that deepening is I initially would have thought from some of the initial maps that we looked at, but we have 998 cyclone there, lots of precipitation out ahead of it. Perhaps some of this could be severe. We can look at some, if someone wants to identify a good section, we could look at some pseudo soundings, if you'd like, for perhaps an earlier time might be better.
So this is going to be a pretty violent tornado outbreak. probably one of the biggest in a few years.
Okay.
It's just looking at this, like more mass scale parameters,
Right.
but in a really favorable time, short way.
Okay, so what's a good time to perhaps look at salvage?
Either 18Z or 0Z.
So before the 18Z on Sunday or
21Z on
Saturday? Okay, so let's go back. So Luke is suggesting it's going to be a significant outbreak, and where do you want to look at? Or if you come up here and just say a few words.
Yes.
Come on.
I would.
Come on up.
You know that.
Look Odell.
Supposed to be
You
interactive.
study, yeah, it's interactive, and you're studying tornadoes? So the breaks.
We go to the head level, if possible.
Luke, are we going chasing that?
It's a little far, that one, mate. I don't know. And if you switch to Zoom or regional, and then you go down on the left here to severe weather. And if we choose the EHI, so this parameter is basically a measure of the energy that rotating updrafts can acquire, and it's basically a mix of 0 to 3 kilometer cape and storm relative velocity. So both of those two parameters can give rise to energy for rotating updrafts, and values in excess of 1 indicate the possibility for supercell thunderstorms or rotating thunderstorms. And so when you see 5, 6, and 7, 8, you're talking about a really volatile environment for supercell type thunderstorms. That is if the storm mode remains discrete or cellular type convection. And so one of the things we want to get an idea of is when the convective allowance models like the HERD suggest that the storm mode is going to be discrete or cellular type as opposed to more of a linear type mode that will form along cold fronts and warm fronts. So if we go over to the left a little bit, just change the parameter. We go do the reflectivity. And as you can see here, really kind of from southeast Texas on the border with Louisiana up to southwest Arkansas, there seems to be a line of fairly or semi-discrete storms. The reason that is because the shear vector, which is a really important thing to look at when you look at the development of severe convection relative to the forcing mechanism for that convection, so is suggestive of whether the storms are going to entrain a lot of precipitation and upscale very quickly into more of a linear type mode or remain discrete. So if they suggest a fairly semi-discrete type cellular mode tomorrow at 4 p.m. across the sort of Mississippi, or sorry, the Louisiana, Texas border. And if we look at shear, if you do the 0 to 6 kilometer shear, the shear vectors are in this region, sort of just behind the front, they're more meridional, but right along kind of where these storms are forming, they're more in a zonal direction, a westerly shear direction. And given that the forcing mechanism is going to be a cold front, dry line feature moving from west to east through that region, with the shear vectors sort of perpendicular to that boundary in this region where the cellular convection is located, that's very indicative of supercell type thunderstorms being able to maintain a discrete type structure. So at least along, especially western Louisiana, if cells can actually fire ahead or develop ahead of the main line of convection associated with the cold front propagated from west to east, then they'll likely remain at least semi-discrete. And the reason that's important is for tornadic thunderstorms, discrete storms, so discrete cells, are much more conducive for generating long-tracked and strong tornadoes. And this is because the processes that lead to tornadogenesis are hampered by cold air and precipitation, generating a very dense outflow at the surface. But once they're able to kind of become sort of discrete and have warm inflow that's separated from that cold outflow, they can actually generate long-lived, low-level rotation, which is very conducive for supercell tornadoes. So to double check the likelihood for tornadoes, we can go down on the left. We could look at significant tornado parameter. And these values, really, again, anything above 1 is suggestive that strong tornadoes, EF2 or greater strength tornadoes are possible. And especially when you get up into these values, up in the 4 to 6 range, which you see a large portion of northern Louisiana is probed to be under at this time, is very suggestive that any discrete cells that do exist over that area, ahead of like the main line of thunderstorms that will be coming through from the west behind, are very, very, very in a very conducive environment for tornadic activity. So given the discrete nature of the storms, the wind profile, which we can have a look at in a second, and the thermodynamics in that environment, it is very likely that any supercell thunderstorm that becomes rooted in the boundary layer or surface-based type supercell thunderstorms will be tornado producers. So we can have a look at the two things that I talked about. Let's first look at, if you go to surface precipitation, and we go to 2 meter dew points of wind bars. We see a surface low feature. It's a little distorted in terms of the pressure field because of the higher resolution and all the convection ongoing at this time. You can see a surface low analyzed in the forecast by the HER here in far northeast Texas. This has a cyclonic circulation around it, which is obviously injecting a lot of moisture off of the Gulf northward into this region right here, which we call the triple point region of the surface low, where you have your warm front sort of extending off to the northeast across Arkansas here, and the cold front or dry line feature extending to the southwest. So this region here is a very favorable region for rotating convection, largely because of the enhanced forcing in this region. In addition to the surface wind bars, you'll notice that they're backed in this region. So what this does is increase the veering nature, the wind profile with height, and both speed shear, but also directional wind shear is extremely important for generating rotation in convective updrafts. And so where we have wind flow at the surface from a southeasterly direction particularly, and then a westerly or southwesterly direction aloft, the combination of those types of wind superposed with one another leads to a strong veering wind profile through the column, and that leads to very conducive environment, kinematic environment for rotating storms. And as you can see, from the thermodynamic perspective, we also have dew points. This is a 70-degree dew point line here. So low 70s dew points are being infected into that region. It's very favorable from a forcing standpoint and from a kinematic standpoint for rotating convection to really fuel those thunderstorms. And so I'm looking at a region right around here for a very sort of very conducive environment for supercells. So let's look at a sounding that will kind of put all that together. Maybe if we go back to the severe weather, and then go back to the helicity parameter. I usually use this as kind of a guide of where to look for the most conducive sounding for this type of thunderstorm. So if you just be careful of these. So I usually don't select anything. You see these little sort of dots along the line there. That's those sort of really small maxima are convectively contaminated environments. So you want to usually just go a little ahead of that. And so clicking in this region right around, something like that. And so what we're looking at here on the left is obviously a vertical profile of dew point and temperature. And you can see an extremely moist lower troposphere. Dew points in the very high 60s. But what's really, really, really important for looking at whether a thunderstorm is likely to produce a tornado versus not in these types of environments is how deep that moisture is in the boundary layer. If you have a really, really moist profile over the lowest 100, 150 millibars of the atmosphere, then very little evaporative cooling processes take place below the LCL there. And so this leads to a lot of what we call warmer downdrafts that are not very dense. And so parcels that traverse those downdrafts tend to be not so negatively buoyant as they would be if the boundary layer was drier. But what that means is that a rotating updraft that wants to ingest parcels that are highly have a high amount of barophilic vorticity associated with them, then they're able to pull or ingest these surface-based parcels up into the storm and stretch the vorticity and to form rotation at low levels, including tornadoes. So this sort of lower thermodynamic profile is extremely, extremely conducive for low-level rotation. Obviously, we need wind shear as well to have low-level rotation in thunderstorms like this. And so looking at the wind profile is the next thing to do. And you can see a really nice veering wind profile. We start off with a southeasterly wind of about 20 knots at the surface, which becomes a 70 or 80 knot southwesterly wind at about between 3 and 6 kilometers above the ground. So that's a huge amount of wind shear, both speed and directional. So you can see that from the photograph on the right up here. This is just showing a plot of wind with height. And you can see that the wind between the surface and 1 kilometer is extremely, the photograph is extremely long, which is suggestive of a lot of wind shear in that really low level of the atmosphere. That wind shear is barotropic vorticity, not barophilic vorticity now. So that adds another degree of vorticity that's available for thunderstorms if they can become rooted to the surface or surface-based. And so the rest of the photograph is large and looping, as we refer to it in scale meteorology, which is suggestive of a large amount of helicity and a large amount of energy helicity index that we saw in the environment. So the hazard type that is then analyzed by the sounding is what's called a particularly dangerous situation, or a PDS tornado outlook. So this type of sounding with a lot of cape, a lot of wind shear, very moist low levels, especially with the approach of the upper level shortwave that we saw and the surface boundaries, particularly if the wind shear, as I said, is sort of perpendicular to that forcing and the storms can remain discrete. This environment is extremely volatile for tornadic thunderstorms in that area. I think that's...
So you give a location, sort of northern Louisiana, maybe southern Arkansas?
Yeah, I would say far eastern Texas. If we go back to the reflectivity.
So the other question is timing. When would you, it's about this time?
Yeah,
or
so
earlier?
if we go back to 29 hours maybe. That's 4 hours.
Oh, sorry.
So at this time, which is about noon,
Yeah.
1 o'clock. So around noon on tomorrow midday, there's a line of convection across just east of the Dallas-Fort Worth region, pushing east. At this time, although what you see here in the shaded region is what we call updraft helicity, which is how helical the updrafts are, so whether they're rotating. There's definitely rotation embedded in this line, but the threat of tornadoes at this time would be fairly small, other than brief, what we call QLCS type tornadoes, which are embedded within a line of pre-existing convection. So although tornadoes would be possible at this time, I would say the threat is going to be later in the afternoon from this time. So if we go through a couple, 2 hours later to 31. Now, out ahead of this line, you've actually got isolated or more discrete cellular convection firing up along the Texas-Louisiana border. So these are the storms that I would say carry the biggest tornado threat tomorrow. But in addition to that, this line you might see is now a little bit more fragmented. The more rotation, the more what we refer to as streamwise vorticity is ingested by the updrafts of convection along the line, the more they can start to become sort of discrete or semi-discrete, as opposed to being sort of a linear type mode, which, as I said previously, is more conducive for tornadic thunderstorms. But these cells here are the ones that I would be watching most intensely tomorrow. So if we go to 32 hours, we can see that these have now gained strength, and you can see these little swaths of shaded region here. That again is updraft helicity. So these cells, at least by the forecast from the HER, which again is not, it's been taken explicitly, but more to give a sort of regional sort of threat area to look at. This sort of cluster in sort of the northern half of Louisiana around about 2 p.m. tomorrow is probably the sort of height of the tornado risk. And then the following 2 hours, as these cells move off to the northeast, I would say the tornado risk is probably largest in that window there. So at this time, it's probably maximized around peak heating, so around 4 p.m. tomorrow, with dew points approaching 70 degrees, with back surface winds in this region, strong veer wind profiles, and deep moisture in the lower boundary there. I would say that probably around this time, if we haven't seen 10 or more tornado reports, I'd be very, very surprised. So it's definitely, as I said earlier, one of the most volatile setups that I've seen in some time from a tornado perspective.
Louis?
Yeah, it's phenomenal. I can't help myself. In this room, we're learning about jets from Frank Seacrest, but we also had to do everything with the opaque projector in my hand. This is phenomenal. But I just want to bring back from the larger scale setup to what you're going at. There's two things that haven't been stated yet.
Okay.
So if we can go to 18Z, 300 millivolt.
You want from the HER or from GFS or some other?
I'll do now because it's larger scale, 4 kilometer, but it's kind of interesting. Yeah, I guess so at some point. But it's really a phenomenal setup from a jet perspective. Yeah, 300 millibar one, just 18 to. So here's the jet.
This is 21.
Yeah, go back to 18. Yeah.
Okay, entrance, there we go.
There we go, right here. So difluent exit region. So the thing is, on the mesoscale, what forces what to adjust? Right? Wind forces mass to adjust. So we were told in this room, trying to see, because we all have biases, right? Look at the wind field. So two things are happening here related to when you're doing the PV,
Yeah.
you're shortening the wavelength between this feature and this ridge holding it here. So you got a shortening wavelength, and you're coming into the exit region. So here's your southwesterly flow along, and the difluence. So I'd be looking at how is the flow going into an unbalanced state, not a balanced state, right? This is really, truly an unbalanced state. So this is the classic gravity wave signal as well. So we should be seeing gravity wave.
And actually, in the sea level pressure, it's really.
Yeah, but you're also seeing it in the convective system as we run forward. That's just what. But also at this point, if you go to 850, we're really at the basics here. The low-level jet is right in the exit region. So that's being forced by the exit region jet, the difluent exit region approaching the range. So all of this is being brought together, not by accident, right? So when you went to so one of the things when Lilly introduced storm relative helicity, he never expected to see people applying that on this larger scale. But it turns out in the cases I've seen, and I've stopped doing research a long time ago, so maybe this thing. But when you get this veering of the wind, right, which is doing the differential moisture and temperature effects, which we need for an outbreak, it's also focusing the helicity in the same area. So that veering of the wind, which is related to this couple mechanism between the upper level and low level jets, is providing a framework. At the same time, the work I did with Franklin Audi and his students, you get this, and Steve Cope, you get the same pattern, actually bringing it right down to the mesoscale and the gravity load. And there was one of those convective systems that you showed was actually showing some kind of that, even though this was the most intense by far, there was some behind it and one up ahead of it. And I was just looking at it from a gravity rate perspective as well. All of this is coming together tomorrow.
Right. So as we could bring up the sea level pressure map, the really distorted features there that I kind of just brushed over, like that look kind of bizarre to me. Maybe on that one.
Yeah.
You can sort of see.
You start seeing it. Now what you have to do is you have to filter out the synoptic scale,
Right.
which was a real trip. I did all that by hand too, right? Pulling all the paragraph cases. So you need like 15-minute data to really be able to isolate the 2 to 4 hour period waves. So but you're seeing signs of a wave activity going around this developing low. This is a very dynamic system with the wind-mass relationship totally out of whack during this period. And then the forcing, the latent heating, the diabatic processes in the boundary layer just compounds the excitement, okay? So but you've got to have this system digging in from a wind perspective. It's there, the veering of the wind. So this low-level jet is developing, the veering of the wind is maxing. It's all getting focused in this. In the gravity wave mode by this decreasing wavelength, it's all getting focused in this area tomorrow, between about maybe 12 to 0. And all the process you mentioned is focusing it right here. So, but I had to do this. I'm channeling Frank Sequist, right? But those jet systems are really bringing it together. It's not happening by accident.
Right.
It's being brought together by the wind fields and the mesoscale imbalances that result from that. That's
right. Maybe just to cap it off, if we go to SPC and see what they're and then we'll come back and look at very briefly at the snow that's coming out.
SPC, the director of which is Russ Schneider, will also have to do
Another Wisconsin.
Yeah, right here.
The outlook for tomorrow.
Yeah, so he's put together
Bingo.
up there. And they went up to a moderate risk with that. So I always start with the wind field.
Okay.
Even when you're in potential vorticity, that's a combination of the wind and mass.
Right.
Right. But the tendency on this thing is really it's being forced by an unbalanced state that's been created. And now the atmosphere is going to try to come into both dynamic and thermodynamic balance by any means possible, which could be tornadic storms.
It really aids in the exit region of that really sharp.
Yeah, it's amazing. It's
The
just,
low inertial stability that you get in that region really helps the outflow of the thunderstorms, which, as long as they can get rid of all that mass at upper levels, and as you say, it's in a gravity. The evidence of the gravity waves existing there, it shows it's really inertially unstable.
so one of the things that Mike Kaplan showed when he started this scale contraction discussion back in the 70s is when you get a jet coming in to a ridge and with a shortening wavelength, even from the divergence equation perspective, both the divergence term and the Jacobian term, they tend to want to offset each other in a normal flow situation. They both lead to divergence or loss, and that's one of the other markers for whether you're in an unstable mode with respect to the dynamics of the system. And I have to believe, looking at the jet coming into a ridge with the shortening wavelength, that's also happening right here.
Right.
So they're all fixed.
Well, thank you, and Louis. So this is a dynamic situation from the perspective of the severe weather that's expected. We'll go back to the NAN.
I want to just share real quick. I'd mentioned earlier about the dust that got into the snow. One of our alumni, Blaine Thomas, is down in New Mexico, and he says, the Midwest has snow days, we have wind days. White Sands Missile Range closed on Wednesday due to the high winds. They made the call Tuesday night. He says the peak wind on Mountain Pass between Las Cruces and White Sands was 102 miles an hour on Wednesday afternoon. They had about 9 hours of sustained 70 to 80 mile an hour winds with peaks at 90 to 100. He said the White Sands posts and locations along the east slopes had frequent 70 to 80 mile an hour gusts, visibility down to 1 mile in the city of Las Cruces and likely down under 200 feet in the dunes out at White Sands. So
They still have dunes there?
They're now in Minnesota.
Right, so we'll step ahead. Let's go to
thanks, Blaine, for the sharing that.
Yeah, thank you, Blaine. We'll see with this. Let's go to 39 hours. Action rolls along. Here's the cyclone 997. It's just approaching Little Rock, Arkansas, and we step ahead. Let's go to 45 hours just quickly since we're nearing the end. We had a great discussion today. 997. So it's not really a particularly intense cyclone, but you can see on the northwestern edge of this, the precipitation, at least the most likely type, is in the form of frozen precipitation. We can do soundings, but don't have the time right now to do that. Go to 48 hours. We get to Sunday morning here. Here comes perhaps our next event. I'll note that the GFS and I think FD3 will quickly look at those solutions as well. A little bit further to the southeast, the NAM, as it characteristically is, seems to be mirroring what the ECWF forecast from last night did. I wonder if it's a combination of very similar model physics or something, but we go to 54 hours, so we'll go into early afternoon on Sunday. We're expecting, if this were to verify, a band of this is instantaneous reflectivity, so it's not accumulation at this point, but the band of precipitation that will extend just to the northeast or northwest of Madison by that time period. Ground is still warm, obviously, even though we've had this chill off over the last couple of days, but there could be some accumulating snow, particularly to our southeast at 9:95, and we'll go to 60 hours. And this lingers over us as we go into the early next Sunday night, where we'll continue to deepen down to 998. If we go to look at this, this is a couple things to note. If you go to look at the just the 10-to-1 ratio, because it's kind of tricky to do this, and you can see a nice band of snowfall here, but let's not get carried away with this. If you actually look at the snow depth in these regions, right, if you look at snow depth, you're not going to believe that. Let's not get carried away last week. But there's still a possibility for some places. This is accounting for, I mean, it's going to be snowing, it's going to be melting, and we have to look very carefully what the temperature structure is at the surface. There's going to be places in the southeastern part of our state that maybe have 4 or 5 inches of snow on the ground once this is done. But that's one model. We don't look at one model, right? So let's look at, although we like the one that produces the most snow. If you look at the GFS for the same time period, hardly anything. It's going to be more realistic. Look at these amounts right here that are in the light blue. You can bring it over there about an inch or so. If you look at FB3 for the same time period, even further to the southeast, so virtually nothing there. So let's not get too carried away, but at least snow in the air, certainly a possibility. Ground is still warm, so we might expect to see some melting. And if you look at the Canadian model, same time period, virtually nothing. Just to our southeast. Again, that's, if you look at total accumulated, just to go back to this for a second. Right, even there, it's showing some to our southeast, the far southeast of us. So the track is still going to be somewhat of an issue. Let's go back to the that's what the FP3 does and the GFS. Okay, so finally, I want to just let's go back to the surface pressure, surface precipitation, or surface event. And going into early next week, snow's over, stay a little bit chilly there, and we're going to really run through this quickly to 96 hours. Again, warming up, looks great, right? So 120 hours. We're now Wednesday morning, maybe some rain, liquid rain, no problem right there, 144 hours. Rainy, okay, it's Thursday, and then we go to 168 hours, and here comes our next potential event, and we can just compare that with the FP3. John will be back. John will be back, and he'll love this. As will I, because it's all going to melt, right? Go back a couple others. Yeah, I don't want to. All right. So this next cycle that'll go by, we'll get cold again, and we'll have perhaps some frozen precipitation in the air. So looking ahead, it still looks like we're not out of winter in terms of snow threats, but again, significant accumulations are unlikely given a relatively warm ground and high sun angle. So don't get too concerned about that. One thing I want to keep track of, we talked about this last week, looking at the, this is something, I don't know how you look at the CFS or if you ever look at it for any purpose into the month ahead, but one of the interesting things is this accumulated precipitation product. We were looking last week, we'll just look at this is for the month ahead basically, but a big concern is the significant, it's been over the last several runs, last week and a half at least, producing 10, 15 inches of rain in the central part of the United States into the central plains and southern plains, into the southeast. And I don't know, I haven't looked at statistics of how well this model forecasts.
So are you using the raw CFS or the one with the skill mask?
This, I believe, is just the raw CFS.
Okay.
Great.
So the one with the skill mask, it's been calibrated. The weeks 3 and 4 forecast, the CFS plays a big role in that.
Okay.
We are now doing the testing the ensemble system out to 31 days in advance.
Mm-hmm.
got a whole different set of biases that have to be worked out.
How many members in that? Let's see if that's.
We're gonna run it with, the full-blown, number of members we have now. I think we have 20 per cycle, so we have 84 per day. Out of that, plus we use the Canadian model, which is another 40-something, for the week swing for. And I believe the Navy model is being used now, too. Again, bias is removed, but it's in there. And, we actually showing a lot of skill, more skill than I thought we would in the temperature forecast. The moisture, the precip this year was actually starting to show positive skill, but it might be because of the El Nino background state.
Right.
So
So,
that's been a persistent pattern.
Yeah.
Just looking that right up Mississippi Valley.
yeah, so that's something so flooding potential, I guess, is just the thing we're highlighting.
Yeah, so I just want to reflect on the climatology aspect of this time of the year.
Sure,
April 9th, 1973, 16 inches of snow right outside this window.
okay,
So it can happen.
right,
But more likely, what I remember about the April snow events was that how many times Chicago got the snow and we got nothing. Because, we had to fly through Chicago to get home, so I remember those very fondly. So,
right. So, and to that, a year, last year, I think the 17th of April, we had like 7 inches of snow.
yeah,
So
yeah,
we know it can happen.
right.
And it's just getting everything right. But the event we had here, 2 inches, was something that the models that initially, again, if you looked explicitly at it, oh, we're gonna get maybe 8 to 10 inches of snow. But we knew that we're gonna lose some of that because of melting. And that's the tricky thing, how quickly can you chill off the ground and how quick the air mass over you?
So the other thing is, for the students, our weekly weather watches only went out for 48 hours.
Mhm.
We were basically looking at the past week more than
Right.
we would. So the big challenge was getting the Sunday forecast right.
Uh.
And, so when you just stepped ahead for a whole weekend, kind of blew my mind.
Right. But sometimes the quality of the models that we're using and
Well,
that's gone into it.
Yeah.
We can actually say
And
something credible
I
about a week ahead.
believe we are outlooking, severe convective systems 4, 6, 7 days in advance. Again, through the ensembles.
Mhm.
So it is remarkable, yeah, but I was laughing when you were going out to Thursday and
Yeah.
Friday.
We did it last week.
Good luck with that. It's good thing you're not grading.
Right. I don't get credit. Right. So they get memories. I know this. Well, anyway, thank you all. Thank you, Louis, for your comments, and Luke for the really great discussion of the severe weather, likelihood of severe weather in the southern plains, particularly over Louisiana this weekend. And so we'll be watching that, and hopefully we'll be back next week to just do a sort of a debriefing on what actually happened. So thank you all for coming, and have a wonderful weekend.